So let's do our final example of a linear contract, which are swaps. So we talked already about swaps. Now let's see how to price them. Okay, so it's going to be a series basically of forward contracts, and here's a bit of notation. So I'm going to only look at the classical interest rate swap. So there will be the payoff of one party. The one party will be receiving the floating rate, the random rate, which I will call L for LIBOR rate, and the other party, and we will be paying the fixed rate. Okay, so a party who is long the swap will be receiving the random floating rate L and will be paying the fixed rate called capital R. And this is going to happen in time at times ti. So there's going to be a sequence of times ti, which are known in advance, finitely many of those, and then the payoff is denoted ci. It's normalized by the length of the periods, and I'm going to assume that each period ti minus 1 to ti has the same length delta t. So delta t is just ti minus 1. There is a LIBOR rate during that period, L of ti minus 1 ti. It's random, but it's known at the beginning of the period ti minus 1 ti. And then at the end of the period, you get the long party gets this payoff, gets the random rate, but pays the fixed rate R. Okay? It's just an exchange of the random rate for the fixed rate. Okay? So, so this is what we want to price. Well, we want to price every CI, and then we're just going to add the price of all CIs to get the price for the total swap. Now, the LIBOR rate, by definition, is this in terms of bonds. I think of P, so the notation here is P ti minus 1 ti is the price of a zero coupon default free bond at time ti minus 1, and the bond matures at ti, and the bond pays $1. Okay, I'm going to assume here for simplicity that the bond pays $1. So the assumption is that P of ti is 1, which means that the bond pays $1 at the end. Okay, it's a zero coupon bond, default free, to make things easier. And why is the definition like this? Well, if you just multiply and rearrange, this just means that okay, if I move things around, it will mean that 1 plus 1 plus L. Let me not write the complete notation. Sorry, 1 plus L times P of ti minus 1 ti and times delta t is equal to so this is not going to be like that. Yeah, delta t is going to be here. Delta t is equal to P is equal to 1. So this just means that if you if you start with this much money and then you increase by the rate, simple rate of L during the period delta t, you will have $1 at the end. Okay, so that's why the definition is like that. It's just in terms of a simple rate during one interval. And I'm going to delete all of this. All right. If I use this definition if I use this definition back in CI, then you can compute. It's a simple algebra to compute that CI is of this form. It's 1 over the bond price minus 1 plus R delta t. Yeah? So I actually have to price this. I have to price these two terms separately, and that will give me the price of the one leg of a swap. All right, so let's do the easier part first, which is 1 plus R delta t. That's just a constant. So this is going to be paid at time ti, right? And we are computing the value. Let's say we are computing the value at time small t, which is less than the first payment of the swap, which is at time t0. Okay? So that's the assumption, that the first payment is at t0, and I'm computing the price before the swap started paying payments at small t, and this amount is paid at time ti. So what is the price? Well, the claim here is that the price is simply that amount, 1 plus r delta t, times the price of the corresponding bond that matures at ti, pays $1, and it's priced at time t. So why is this? Well, because the bond, by definition, is a zero coupon bond. Is by definition, if it's paying $1, p at small t is the price of $1 at small t. Now, this is 1 plus r delta t dollars. So if the price of $1 is p of t ti, by the definition of the zero coupon bond paying $1, then the price of 1 plus r delta t dollars is just 1 plus r delta t times the price of $1. Okay, so that's easy. It's easy to price 1 plus r delta t. That's the constant part of this formula for the payment of one leg of a swap, or one swap payment. So let's look now how to price the other term, this 1 over the bond price. Okay, let me just try to get the okay. So let's move to the next slide. So here is a claim. We claim that the value at time t less than t0, we are still sitting at some initial time before the swap payment started, and we are looking at this payoff 1 over p of ti minus 1 ti. But that's the payoff. We know this payoff of ti minus 1, but it's paid at time ti. Okay? It's paid at time ti. And I claim that the price is equal to exactly to p of t ti minus 1, to the bond price at time t of a bond which matures at ti minus 1. Okay? So how does one prove that? Well, we could do the replication argument by just assuming that we invest this much. Let's say we invest p of t ti minus 1 at time t, right? By buying a corresponding bond which matures at ti minus 1, right? Which means that we are going to get $1 at time ti minus 1. That's what the bond price is. I'm going to get $1 at ti minus 1. How many ti bonds with maturity ti can I buy? Well, I have $1. This is the price at that time. So at time ti minus 1, I have $1. And at time ti minus 1, this is the price of a ti bond, the bond which pays $1 at ti. So since I have $1 and it costs me this much, I can buy 1 over that price bonds with maturity ti, right? So if it's just I have $1, it cost me p dollars to buy 1 bond, so I can buy 1 over p bonds. Okay? Okay, which means that at time ti, I'm going to have exactly that many dollars, because 1 bond gives me $1. So 1 over p bonds will give me 1 over p dollars at ti. Okay? So it's going to be 1 over p ti minus 1 ti, which is what I get at ti, and that's it. So the price of this payoff is p of t ti minus 1, because we just did the replication argument. Starting with this at time t, we ended up with 1 over p ti minus 1 ti at time ti, which is that second payoff in the formula. Okay? All right, so if we put them together, we have that the price of one swap payment is p of t ti minus 1 minus 1 plus r delta t p of t ti. All right. Well, then the price, let's call it S of lowercase t of the whole of the swap, is just the sum of the payments of the prices of all the payments across time. Let's say there are n times and periods and times payment. So the price S of t of a swap is going to be the summation of all these prices from I1 to n. And then I just put them in. I just put this formula in here, sum them all. And there's going to be cancellations, right? If you look at here, I have P of TTI minus 1, and then and then I have 1 times P of TTI. But here, for what is now Ti minus 1, what is now Ti was Ti minus 1 before, and so on. So there will these terms will cancel. There will be terms which will cancel. And if you do the algebra, I'm just going to leave that to you. You will end up the R delta T terms don't cancel, but other terms cancel except the first one and the last one. Okay? So these other terms will cancel except the first one and the last one, and then R delta T terms don't cancel. So the total formula for the swap is P of TT0, the bond, the price of the bond with the maturity at the first payment of the swap, minus swap rate. R is called the swap rate. The fixed rate is called the swap rate. Delta T times summation of all the bond prices with all maturities minus the price of the bond with the final maturity of the swap. Okay? So it's a simple formula. It's as we already kind of indicated. It's a linear function of the underlying asset. I mean, the underlying asset is kind of the rate, but it's also linear in the bond prices. Yeah, so you can think of the the price of the swap is simply a linear function of the prices of zero coupon bonds paying $1. Yeah? So that's simple enough. Now, as with the forward or futures contracts, when you enter the swap, you don't pay anything at that time. So at small t, there is no exchange of money. So actually, theoretically, we can get a formula for R for the swap rate, which will make, in fact, this price equal to 0. Okay? So and that really is called the swap rate. So let's look how that works. So remember the formula. Go to the next slide. I'm just repeating the formula here. So by definition, the swap rate, the market swap rate, is the one which makes the cost of entering the swap at initial time equal to 0. So I'm going to put small t equal to 0 just to be specific here. And then if you compute from this equation, put small t equal to 0 and put 0 here for the value of the swap at time 0, and then compute R from that equation. If you compute R, you're going to get this ratio. Yeah. So this is the theoretical formula. What the swap rate should be in a perfect market in terms of default-free zero coupon bonds paying $1. Okay, in reality, you don't really have zero coupon bonds default-free which pay exactly $1. But you know, this is theoretically the formula expressed in terms of such bonds, and then in practice you can adjust for what you have, and you know, this is what the swap theoretically what it should be, but in practice it might be different from this. Right. All right, so that's the pricing of swaps. It's really finding the fixed rate that and so this would be the benchmark way to, if you go and enter a swap with a counterparty and you are long the swap, they would use something like this, at least as the simplest, in a simplest model. They would use something like this to tell you how much you would have to pay as a fixed rate in order for them to pay you, say, the LIBOR rate. Okay? This would give you this would give them a way to having a benchmark number, benchmark value for what the rate in the fixed rate in the swap should be. How much they should charge you in terms of the fixed rate in order to pay you random rates every period, and you pay them R. All right. So that's the swap rate formula. Let's move forward. Let's do an example just to fix the ideas and just put some numbers in here. All right, so let's assume that there is a swap counterparty, swap investor, who receives the fixed rate. So he receives the 10% fixed rate so he's short the swap. And the payments are every 6 months, semi-annually, so every half year. And the investor pays the 6-month LIBOR rate. Okay? Let's assume, to make things a little bit more interesting and not completely the same as in the previous couple of slides, let's assume that the swap has already started and there is 9 months left to maturity. Okay? And at the last payment date, or resetting date of the swap, the 6-month LIBOR rate was 6%. Okay? And the continuous 3-month and 9-month rates are now 5% and 7%. Okay? Let's assume that this swap is written on the nominal principal of 10,000. This is just to know how, what kind of, how much the payments will be. All right. So if you want to use the notation from the previous 2 slides, T0 already happened. Okay? T0 was 3 months in the past. T1 is going to be the next payment, which is 6 months from the beginning, which is 3 months from now. Okay? So T1 is going to be 3 months from now. And then finally T2, which is also the final payment, is 9 months from now. And delta T, we are measuring things in years. So in years, it's going to be 0.5. Okay? So I cannot actually directly use my formula from before, because my formula was for the price of the swap looking from the point in time which is before T0. Okay? T0 has not yet happened, and then I computed the price of the swap. Yeah, but here I'm sitting at the time after T0, so I'm just going to repeat for exercise the same type of logic and price this swap term by term. I cannot quite use the formula from before again, because I'm at a different time. The swap has already started. So there's going to be 2 payments, right? There's going to be payment C1 3 months from now. We already know how these payments look like. They have this form. And this is on 1 unit of notional principal. Then at the end, I'm just going to multiply everything by 10,000. I want to see what how this investor will do in a swap like this. Okay, so there's going to be that payment 3 months from now, and there's going to be a similar payment 9 months from now, except then it's going to be P of T1, T2 here instead of P of T0, T1. But this term is the same. Okay. So I can pay these by the same logic that I applied previously for my general formula. I can price these terms. So let me first price C1. Okay. So this is P of T0, T1 is known at the time that I'm sitting at, right? Because T0 has already happened. So this is the price of the bond at T0, but T0 is in the past, so I know this. So I know both this and this. Okay? So it's a constant term that I have to price, which will be paid 3 months from now. So I know how to price it. This many, the $1 costs, is equal to the price of the if it's paid in 3 months, $1 is going to be the price of the 3-month bond. And this many dollars, 1 over P T0 T1 minus 1 plus R delta T, is going to be that times the price of the 3-month bond. Okay? But I'm assuming that I know in terms of a continuously compounded rate what the rate of the 3-month bond is, and it was assumed to be 5%. Right? Yes, the 3-month rate was assumed to be 5%. So I just multiply the bond price is E to the minus the rate times the time in years, 3 months it's a quarter of a year, so 0.25. Okay. All right, so that was pricing that payment, which is known at the time we are looking at. So I just multiply by the price of the 3-month bond. And then, actually, well, I said it's known, but we have to compute it. I didn't give it to you in the information in the previous slide. So we actually have to compute it. How we can compute it? Well, we have this definition of the LIBOR rate, which can be written like this: that the price of the bond times the LIBOR times delta t should be 1. Okay? Since I know delta t and I know the LIBOR rate, it was given in the problem as 6%, then I can get that p is 1 over 1.03, and I can plug it in here and I can compute C1, and I get a negative number, minus 0.0198. Okay? All right. So that was pricing the payment which will be paid 3 months from now in the swap. And finally, I have to price the payment which will be paid 9 months from now. And so that payment, remember, I already priced something like that, right? I said that let me look at the payment again just before we argue here. So this is the payments. So this one is easy. I'm going to just multiply by the price of the 9-month bond, the constant term. But 1 over p term, I have to do that logic that is the price. This is going to be paid at T1. Sorry, at T2, but it's not at T1. So by the logic of the previous slides, if you remember, the price is just P of TT1. Okay? Okay, so you just go back a couple of slides, and that is that's P of TT1. This one is the same as before. You just multiply 1 plus R delta T by P of... Okay, but now you multiply it by 9 months. Sorry, and it's not quite the same. You now multiply it by the 9-month bond rather than by the 3-month bond. Okay, so okay, P of TT1, that's the bond which that's the 3 month. T1 is 3 months. So I already know the price. It's e to the minus 0.05 times 0.25. Okay, that's just a 3-month bond. And then here I have to multiply by the 9-month bond. R is known to be 10%. Delta T is every half a year, so it's 0.5, 1/2. And then T of T2. T2 is 9 months. And I also so the rate was the 9 months is 0.75, and let's go back. So and the 9-month rate is is 7%. So I think I have a typo in the next slide. So let's deal with it. So this should be, let's try to get a ballpoint pen. So this should be 0.7 here, not 5. Okay, and then you get you get a number. I'm not sure whether now this is correct or not, but you can check that yourself. And then if we go here, if we add up those two values, you get a number which is negative. That's and then finally this was actually I think this was for the long position, and our investor is short the swap. So his value is there was 10,000, and it was the nominal value. So you multiply the 10,000 by whatever number you get here, with the minus sign, and that's the the total swap value at the time 3 months after T0, at the time we were looking at. Okay, so this is this example. As you could have noticed, there was a couple of typos in the last 2 slides. So I'm just going to leave that to you to figure out exactly whether everything is corrected.